In this video, we will be looking at section 6.1, angles and their measures. We will be looking at the different types of angles, different ways to measure them, and looking at towards the end at some formulas that involve our angles. And so let's just get started off with just some basic definitions to make sure we are all on the same page, as we'll be using these terms throughout the entire semester. First, what trigonometry is a lot about is angles. So let's define what an angle is. An angle is going to be determined by rotating a ray about its endpoint. And this can be rotated both clockwise and counterclockwise. So for example, a ray would have a point, and then we would have some line going any direction. Mine's just going this direction. And this would be considered your initial side that I drew here. And then we're going to rotate that either clockwise or counterclockwise. It doesn't matter. I'm going to rotate mine counterclockwise for this example. And I'm going to rotate it up to that point right here. They should be the same length and straight lines, but I'm not always going to be able to do straight lines when I draw this stuff. So that rotation there from that initial side to the side I ended on, which is called the terminal side, that rotation is an angle. We usually denote angles by Greek letters, though you can use any letter or symbol to denote an angle. The most commonly used one is theta, which is a circle with the line through the center. That is the Greek letter theta. And again, that is the most commonly used letter to represent angles. So I will use that one pretty frequently. So that there is our first angle. From that, we have a few different types of angles. First, we're going to look at a positive angle and a negative angle. The angle that I drew right above there with that rotated ray, that is considered a positive angle because I did a counterclockwise rotation. A negative angle is a clockwise rotation. A positive angle and a negative angle, one is not better than the other. It just determines the direction in which you're rotating. From that, we have our first way we're going to measure these angles, and that is with degree, what you are probably most familiar with. Well, if we're looking at 1 degree, our unit of measurement there, 1 degree is going to be formed, not if, is formed by still doing that rotation of that ray. Rotating that initial side of your ray. And you're going to do that rotation of that initial side by 1/360th of a complete revolution. Now the vertex is just that point. So back up and that drawing I have above this point up here, that is considered the vertex. So I'm doing 1/360th of a complete revolution. That is going all the way around 360 degrees. That, as you probably know, forms a full circle. So 1 degree is just doing 1/360th of that complete revolution. And that's going to be how we're going to be measuring degrees. From that, we have a few classifications of angles. First of all, we have an acute angle. That is just an angle that is between 0 and 90 degrees. Please make sure you are using that degree symbol when you're referring to degrees, because we will have another measurement, and having that degree measurement will help us distinguish between the two. An obtuse angle is an angle between 90 degrees and 180. A right angle is 90 degrees. We're going to be dealing with right angles a lot in the first chapter. Straight line is 180 degrees. So now let's look at another type of angle, and this is called a coterminal angle. You can have more than one coterminal angle, and these are angles that have the same initial and terminal sides when you do that rotation of that ray. I'm going to draw an example of that. I'm going to start drawing our angles on the XY coordinate plane. It'll make it easier when we're doing some of our work. So let's look at our first angle. And I'm going to call this first angle alpha. So let's say I'm starting here. The origin is going to be that vertex point. I'm going to have my initial side there in red. Again, this is just a sample drawing. That initial ray could be pointing any direction and be any length. I'm just going to rotate this one up to here. This first angle there, I'm going to call it alpha. There's the Greek letter, alpha. So we have our initial terminal side. I do that little arrow in between my initial terminal sides so you know what direction I am rotating, because if I did not include that, you wouldn't know if I was going clockwise or counterclockwise. Now, coterminal angle to my red angle alpha, I have to start with my same initial side and end at the terminal side. That angle there, rotating that direction, that is a coterminal angle. I'll call that beta. You do not have to use Greek letters. You can use any letters or symbols to represent these angles. Alpha and beta are coterminal angles. I could also look at, starting with my initial red angle there, alpha, I could start here and rotate around twice and end there. And my green angle is also coterminal to alpha and beta. So I can keep going around and rotating and rotating and rotating around multiple times, so I can get infinitely many coterminal angles. So to determine some coterminal angles, we're going to have two formulas, and that depends on if we want to go clockwise or counterclockwise for our rotation. So if you are given an angle, and I'm just going to call it theta to begin with, so I can use that in my formula, you can find a coterminal angle in the following way. So there's going to be two formulas. So you have an angle that you're given and you're asked, hey, I need a coterminal angle. Here's going to be the ways in which you can find those. You can take your angle that was given to you and add 360 degrees times n. Now, n is looking at the number of times you're going to be rotating around. N starts at 0, then 1, then 2, then 3, all these whole numbers because we're doing full rotations around. Or you can use this formula, theta minus 360 degrees n. So it is up to you. If you're just asked to find any coterminal angle, you can use either formula and use any value for n. Hence why there are infinitely many, because there's infinitely many n's that you could choose to find these angles. So let's do an example of finding a coterminal angle. And we're going to look specifically at Finding an angle that is coterminal to 860 degrees, that is between 0 degrees and 360 degrees. So here we have a little bit of restriction about the coterminal angle we want. If you're asked to just find any coterminal angle, you don't necessarily have to worry about these constraints. So my initial angle given is 860 degrees. That's my theta. I need to find an angle that's between 0 degrees and 360 degrees. So first though, let me draw out what 860 degrees looks like as rotating around. So I'm always going to start here, and it's positive, so I'm going counterclockwise around. I know if I go around once, that's 360 degrees, so there's my one rotation. If I go up to here, I'm going another 90 degrees, and another 90 degrees, another 90 degrees, and if I do again, now I'm on my second rotation around, that's another 360 degrees. I've now gone 720 degrees as I'm wrapping and rotating. Now I'm going to go another 90 degrees, so if I end up right there at that North Pole position, if I take 270 degrees and another 90 degrees, that gets me to 810 degrees up there at the top. If I keep going another 90 degrees to here, that will put me at 900 degrees. So I know I've gone way too far because I only want to go 860. So that means I end up somewhere in here. That's my angle theta. Now it's not necessarily to scale. Okay, so none of my angle drawings are ever going to be to scale. So it looks like it's approximately 860 degrees. Not perfect, but we just care about that's where it's located. I ended up in that second quadrant as I rotated around. Okay, just so we have a general picture of what 860 degrees looks like as we would be rotating that initial side around. We had to go around twice, fully, and on our third time around, we didn't even make it halfway. Okay, so now we want to find an angle that is coterminal to that 860 degrees, but that coterminal angle should be between 0 and 360 degrees. So we're going to look at those two formulas there off to the side in green. And if we want it to be between 0 and 360 degrees, I probably want to use the second one, because if I'm adding 360 degrees in that first formula there, that is going to be outside of the window that I want to restrict my coterminal angle. So I'm going to be using theta minus 360 degrees n. I know my theta is 860 degrees. Now I just need to pick an appropriate n. If I let n be 0, I'd have 360 times 0, which would get me 860 degrees. That's an angle that's coterminal to itself, not very fun and exciting, and also it's not between 0 and 360. Not very useful. So I can't let n be 0. Let's try letting n be 2 and see if that works. Okay, so we have our 860. 360 times 2, oops, that should be a minus, not a plus. 360 degrees times 2 is 720. If I take 860 minus 720 degrees, I do get 140 degrees. And that is an angle that is between 0 and 360 degrees. So that is a valid coterminal angle. So if I were to look at drawing that, I started here and I want to go to that terminal side there. There in black, that's my 140 degrees. So now I have my two coterminal angles, 860 and 140. That's just one of infinitely many possibilities. Again, we were just restricting ourselves between 0 degrees and 360 degrees. No special reason why. We just did. So we are going to stop here for that first half of section 6.1, where we looked at definitions of angles, coterminal angles, and degrees. Our second half of 6.1 will look at our second angle measurement of radians and also doing some formula work with that radian measurement.